All right, it's recording. Here you go. Exercise 9E, tree diagram notes. Let's go. Tree diagrams. We use them to list, and what you write here, this is sample space for experiments with 2 or more steps. Write that down. So when do we use tree diagrams? Tree diagrams is a tool. It is to help you visualize your problems when you have 2. Thanks, Idris. When you have problems that has 2 or more steps. So what do I mean by that? You see, if I ask you right now, let's say, let's go with Emma. If I roll a dice and I ask you, what's the chances of getting a 3? What would you say? 1 over 6. So you got 1 in 6 chance of getting a 3 because there's 6 numbers that you can get from rolling a dice, and there's only 1 3 out of the 6. So you'd say it's 1 out of 6 chance. This is called a one-step problem. So most of us can do that. That's one of the first exercises, 9A. Yeah, so if you do 9A, that's part of your homework down as well. So 9A, probability of 3, easy. What's a 2 or more step problem? I might ask you something like this. I might say, well, what if you roll the dice twice? So you roll it once, you roll it twice, and then you flip a coin. So this is coin, this is dice, dice. Now what if I said to you, what's the chances of getting even number on the first go, even on the second again, and then I want tails? Now we can work this out. See, the first one was easy. If I asked you what's the chance of getting a 3, you had no problems. But as soon as I introduce multiple steps, so what's the chances of getting an even number on the first go, even number on the second go, and then on the third go, you need to get a tails. What's the chance of that occurring? Now, for some of us, that might not be doable in our heads. For some of us, we can do that. We can kind of figure out all the possibilities. But that's what I'm saying. What if you're not that type? What if you can't do it in your head like some people? I'm definitely not that kind of person. I'm the kind of person that needs to see something. So this is where we use a tree diagram because there's multiple steps. So how do we do this example? Here we go. Let's have a look at, I'm just going to delete this so that you see the difference between one step and multiple steps. Example 1. Oh, hey, this is similar to the one I just said. If you had 2 regular sided die and you rolled them, and then you note down either odd or even. So what they're saying is you got 2 dice, you roll the first one, you note down, is it even or odd? Then you roll your second one, and then you note, is it odd or even? So if you have a look here, this is hard to figure out if you're trying to do it all in your head, but if we write it out, it's pretty logical. On the first dice, so I write here, first dice. If I roll a dice, what are my possible options? I get 1, 2, 3, 4, 5, 6, but I'm only interested in whether it's odd or even. So what are my options? What are my options? When you roll a dice to get an even number, what are the possibilities? What's the even numbers? 2, 4, and 6. So those are your options when you roll a dice. To get an even, it's 2, 4, or 6. What about getting an odd? What are my numbers? 1, 3, and 5. Very good. So we've got 1, 3, and 5. Now, on my first dice, I could get 2, 4, or 6, which is an even, or I could have got a 1, 3, or 5, which is an odd. What's the chances of getting an even? So this is a one-step problem. Back to exercise 9A. 1/2, because there are 3 numbers out of the total 6 numbers that could be even. So right here, I would say the chances of getting an even is 3 out of 6, or you can say 1/2. You got 50% chance of getting an even. What about an odd? What's the chance of getting an odd number when you roll a dice? Let's go with Idris. You roll a dice, what's the chance of getting an odd number? 1 over 2. You got 3 numbers there, 1, 3, and 5 out of 6 options. So again, 3 out of 6, you got 1 out of 2. So you got 50% chance getting even, 50% chance of getting odd. That's on the first go. Then you got your second dice. When you roll the second dice now, this is where the multiple steps come in. This is where the tree diagram shows you. You could have got on your second dice, here's the second dice. This is the option. You might have got even on the first go. And on your second go, what are my possible options? Well, it could have been even, then odd. But you might have had even, and then on the second go, it could have been even as well. So that means your 2 possibilities here is first go could be even, Second go could have been odd, or second go could have been even. These are your sample space. So tree diagram helps you to visualize what are the possibilities that can occur here. Now let's think about it. What's the chance of getting odd again? What's the chance of getting odd? So you roll the second dice, what's the chance of getting an odd? Still 50. A lot of students get a bit tripped up here because they're thinking it's the second branch. In this case, you're still rolling the same dice. It's still got 6 options. To get an odd, it's still 1, 3, and 5. So you still have half a chance to get an odd on the second go, and you still have half a chance to get an even. Now, what students don't understand is when I say, what's the chances of getting an even and an even, we knew the chance of getting an even was 50% for the first go. To get another even, that's another 50%. And the language here, if you didn't realize, you're saying, what's the chances of getting even? It's 50%. And then first even's another 50%. So what you're really saying is, what's 50% of 50%? Think about it for a moment. What is 50% of 50%? What's the logical answer? What's 50% of 50%? 25. 50% just means half. You're just really saying, what's half of 50? See, 50% of 50% is 25%. That's a logical answer. But if you were to write it out as a fraction, that's 50%. This is 50%. So what you're really doing is half times half. So you're multiplying these two branches together. Can you see? Even times even, half times half is a quarter, which is what Emma just said was 25%. So a quarter is 25%. See that? That's equal to 25%. I'm talking about percentages because most students understand what I'm saying. If I said a quarter, most students don't get it. So I'm sort of speaking in that language in percentages, but we often work in fractions. Okay? So how do you do even then odd? It's the same thing. To get even on the first go was half. Chance of getting odd on the second go was also half. So you actually have a quarter again, 25% chance of getting an even then an odd. Let's do the others. You could have got an odd then an even, and you could have got an odd with an odd. So it could have been odd, 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 even. Now if we work out the percentages for each one, chance of getting odd and odd is half times half again. And hopefully you figured out the pattern. This was an easy example that are all 25% chance of getting either one. Your problems that you're going to work with doesn't always end up being half, 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 half. It might actually be half, 3/4, depends on the problem. But the first thing is to draw out the tree diagram to help you visualize the problem. Here's my sample space. This is all the possible options you can get. Even, odd, even, odd, odd, or odd, even. Those are the possibilities if you roll a dice and you want to check if you have an even or odd. Okay, so let's answer the questions now. Once you've got a diagram, answering these questions are easy. Find the probability of rolling 2 even numbers. What's the chances of rolling 2 even numbers based on our calculations so far? What is that, Emma? Yeah, 2 even numbers is over here. So I want you to get used to using notation. PR for probability, E for even, and you want another even. So we use intersection. This is the symbol for intersection. So and another E. So E and E just means even then and even again. That was 1/4. And we already know that's 25%. Let's do the next one. What's the chances of picking or getting an option where you have one even number? So look at your list. How many of them have one even number? How many of them can you see? One even number. Yeah, there's only 2. There's either you can get even first and then odd, or you can get odd first and even. If you add those 2 together, the chances a quarter plus a quarter is equal to 2/4, which is equal to a half. But the logic to it is you're actually working out 2 branches. You're actually calculating even then odd, that's one branch. Work out the percentage for that, which is a quarter. Then you add it on with odd and even. Those are the 2 branches you're adding. So half times a half gives you the other quarter. Half times a half gives you the other quarter. And together, these 2, when you add them together, that's how you get 1/2. So how do you write the notation? This is what it actually looks like. You're meant to write probability of getting an even first and then odd, plus probability of getting an odd first and then even. See how I'm doing it? I'm just following the tree branch. So I only want 1E. Well, these are the two options that I can get 1E. So I can get E first, then O, or O and then E. These are my two options. And it ends up being a quarter plus a quarter is 2/4. Or if you like, I can spell it out a bit more. I write it out. It's 1/4 plus 1/4. That's how I got 2/4 equals half. Last one. What about probability? At least one is odd number. So at least one odd. How would you do that? So out of your list so far, what's the chances of getting at least one odd? How would you work that out? At least one odd. So in the group, I need at least in the options, you have to have one odd number. Give me the answer first. Ooh, no. You're probably missing something. I think I know what you're thinking. It's more than half. It is 3 out of 4. Why is that though? Very good. So I said at least one, so it could be one or more. So this has one O odd. This has one odd, but because we said at least one, you should also consider this option as well. So this one has at least one odd. This has at least one odd. This has at least one odd. That's the only one that doesn't have any odds at all. So you actually got 3 out of the 4 options there. So you need to add these 3 probabilities together. Chance of getting this first one is 1/4. Chance of getting this one is another quarter. And this is also another quarter. So quarter plus a quarter plus a quarter gives you 3/4. So if you were to write out the proper notation, it should have been probability of E and odd plus probability of odd and odd plus probability of odd and even. Together, that gives you 1/4 plus 1/4 plus 1/4. That's how you get 3/4. Okay, so what's key is once you do the tree diagram and you write out your sample space and you work out the probabilities for each one, it is easy to calculate. This one is probably the one that most students get wrong. So if I put in a test, most students will get the first one. It's the last one that I often get zeros for, and it's because they're not practicing enough to get to these type of questions. So you want to get to the ones where it says at least or more than. Okay, so when they say more than 2 or at least 3, your aim is to get familiar with how to work out that probability. Most students will do the first one fine. It's the next few that I want you to get comfortable with the tree diagram. Does that make sense? Now with the other class, once they got a feel of this, the next one, I'm going to pause the video and I want you to try to draw a tree diagram for this scenario. Okay, so if you flip over to your notes on the next one, so next page, here we go. So this is all on OneNote if you need to sort of follow up on it. But here we go. Let's go to the next page. This is your challenge. I'm going to pause the video here. And I want you to have a go at reading this question. I'm going to explain it to you. And then I want you to think how many possible options there are. And I only got one student who gave it a crack and then got it right. And then many others got this wrong. So it's okay to get it wrong. I want you to give it a crack though. Yeah? So here we go. And you also got bike, car, train. Bike, car, train. So if you draw it out, listening eyes and ears towards the board. So here's the quick way. What's the quick way of figuring out the total options? Hopefully you realize that for every option, so the first one had 2, so I'm going to write 2 here. Hopefully you realize there's a pattern here. First one has 2 ways. The second one has 2 ways. And the third one has 3 ways. But what you need to realize here is that in the second one, for every answer you got here, there's another 2. So what you're doing is you're doing 2 lots of 2. So 2 times 2 gives you the 4 options here that you can see. That's 1, 2, 3, 4. So 2 times 2 is 4. But then for this third column, to get to C, for every answer you got here, there's 3 options. So it then becomes 3 times 4. So if you actually multiply them all together, 2 times 2 times 3 will give you the answer of 12. And you can do this for a lot of things. Like, for example, if you woke up in the morning and I said, you get to choose your t-shirt. Let's say you got 5 t-shirts. And then you've got 3 pants to choose from. And then an accessory, you've got 10 accessories to work with. You don't have to draw a tree diagram to figure out how many possibilities that you would do. You can actually just work it out. 5 options, you choose 1 t-shirt. 3 options, you choose 1 pants. 10 options, you choose 1 accessory. You can actually work it out by just doing 5 groups of 3 and then times 10. 5 times 10 is 50. 50 times 3 is 150. So I already know there are 150 ways that you can dress up with 1 t-shirt, 1 pants, and 1 accessory if you had 5 different t-shirts, 3 pants, and 10 accessories. That's a quick way of doing it. Or you can draw a tree diagram if you want, but that's where the logic comes from. So that's how I knew, looking at this example, there's a total of 12 outcomes. So write that down, it's 12 outcomes. And once you've got the 12 outcomes, from here, now you can answer the questions. I want you to fill this in as part of your notes. Here we go. Before you fill it out, let's answer this part. Boys, active listening or actively taking notes, thank you. Here we go. So under these trees, let's actually work out the chances. So for the first one, when you're going from home to A, what's the chance of you picking a train and what's the chance of you picking a car? What's the probability? Yeah, it's 1/2. It's not a trick question. It's just you got 2 options. You got 1 out of 2 to choose a train and 1 out of 2 to choose a car. So you got 50% chance choosing a car and you got 50% choosing a train. What about once you get to A? What's the chance of you picking a bike or a train? What's the chances? Should also be 1/2. But the difference is the third one. From B to C, what's the chance of going on a bike again? It's not 1/2. This time it is. What is it this time? What's the chances? Bike, car, train? 1/3. So you got a third of a chance to get a bike, third of a chance to choose a car, and a third of a chance to choose a train. So when you're filling out your tree diagram, make sure to put in the percentages or the fractions, because that helps you calculate the answers later. So here, let's try this one. I'm just going to move my mouse down. In your tree diagram, I want you to fill in the numbers here. Here we go. Train was 1/2. This was also 1/2. This was 1/2. This was 1/2. And your last ones are all 1/3. So it's 1/3, 1/3, 1/3. We'll just leave it there for now. But now if you were to calculate the answers, what is all your total possibilities? Let's count them. You could have done train, bike, bike, train, bike, car, train, bike, train, 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 train. Can you see how I'm just following the tree diagram? Tree, bike, bike, train, bike, car, train, bike, train. That's my 3 options there. And then train, train, train is that third one there. Yeah, so I can keep filling it out. Train, train, bike, train, train, car. That's so far 1, 2, 3, 4, 5, 6. I've got half the options. If you do the other half now, you could have started off at C, car, bike, car, car, bike, bike, car, bike, train. Then you can do it again. Car, train, bike, car, train, car, and then car, train, train. I should have a total of 12 now. 1, 2, 3, 4, 5, 6, and that's another 6. So that's 12 options there. So that's all your possibilities there. Now that you've got your possibilities, you can work out your answers. So have a go. I'm going to pause the video now. I want you to have a go at answering the question. So these are the options. So they might say, what's the chances of picking all trains? There's only 1. And to work this out, it's 1/2 times 1/2 times 1/2. Also 1/2, 1/2, 1/3. And that will give you your answer for train. Okay, so just getting used to using the tree diagram to work out your chances. That's how you do multiple step experiments. Yeah, I'm going to pause the video.